Okay, so for more example, just go through the textbook, see more examples. That is the okay here. So we do this one. This time x squared sine of x. Okay, so let's see. Oh, by the way, can you see already the textbook that I show you?
Yes, sir.
Okay, here is integral x squared sine x. So let's here we let u equal x squared, and then dv is the rest, sin x dx. And take derivative, so du is 2x dx, v is integral of sine x, so just negative cosine. Okay, so u times v is x squared, x squared times negative cosine. We have here. And here we have v du. So negative cosine x times x from here. So you have take the 2 out and take this negative out. So make this into a plus. But now we have this integral. We use another by parts. Okay, so here we use, let me just, u equals x, dv the rest. Okay, so here du equals dx, and v integral cosine just sine x. Okay, so we have uv x sine x here, and x sine x plus integral of v du, integral of sine x dx. Integral of sine is negative cosine. Negative cosine, this become plus. Okay, so basically this is, let's see, let me write this down. X sine x minus integral of v du sine x. Sorry, is there any? Oh yeah. Okay, so this integral of sine x is just negative cosine, so it makes this positive. Okay, so this is what we have. Right, so applying integration by parts twice. All right, so let's do this one here. E to the x times sine x. We take u, the exponential, and then the rest is just dv. So the du is take derivative e to the x, again this e to the x, and v integrate sine become negative cosine. Then you use substitute to this integration by parts. U times v, so e to the x times negative cosine. Okay, and then integral, negative integral of, subtract the integral of v du. Negative cosine, make this become plus e to the x. Okay, but integral, this one, this integral, e to the x cosine x, and the original integral is of the same level of difficulties. They are of the same level. Why? Because still this is exponential. This is trig function. Sine x or cosine x doesn't matter. They have the same level. Okay, so this. So then let's do another integration by parts with this one, e to the cosine x. If you compute this integration by parts here, we get this one directly. Okay, this is the choice, e to the x cosine pv. Okay, so u times v is e to the x sine of x. Again, subtract the integral of v sine x dv here. Sorry, v du. So sine x e to the x here. Again, this is, let's see. So in the end, you have this integral equals negative e to the x cosine x, right? Plus this replaced by this. Okay. And now notice that the observe this two here. See? The original integral reappears on the right-hand side. Okay, so you remove this here. This is negative. There are two of this. Okay. See, this is, you combine this one, the left-hand side, you get two of them here. Okay, from which we have this, just take 1/2 of this. Okay. So this example show you that it doesn't matter the choice for u dv, you can interchange this. Okay. So there are examples when the choice for u and dv is important. This example, particular example, you can take either one. Okay, so skip this one. Okay, so where's the other example? Let's see. Let's go back to. Okay. Do this one, for example. Okay. T to the 6th ln of t dt with the integrate from 1 to 2. All right, so the choice is this one. U equals ln and dv equals t to the 6th dt. All right. By this choice, we have du derivative, so 1/t dt. And v is integral of this, so 1/7 t to the 7. You plug it in, u times v, okay? And then this integral v du. So this one. And you plugged in the number, the boundary. So from 1 to 2, plugged it in. And here, this integral now. So you see, this integral now is just integral of this polynomial. So that's easy. Okay, then you can compute this one. Okay, so let's do the other way around. What if you choose v is the polynomial? Okay, so let's do this one. Let's write it down. Where is that? Okay. Let me notice here that the with the choice plus ln of x, and the v is t to the 6. This is textbook. Page, whatever, let me check. Example 4, page 388. Okay, so let's do the with the choice then. What if u equals t to the 6? You might attempt to attempted to use this one. dv is ln of t dt, right? So here we have du equals 60 to the, while v is integral of ln of t. Well, this is the problem, because integral of ln is, well, we computed earlier. Let's see which example. Let me just copy this one here, right? So example 3. Back. Here we have So we have here is this integral becomes, this integral is u times v, u times v. Oh, sorry, this should be here. Just take this one. Things, yeah. Okay. So this gives you u times v. Sorry, should be x, but e. T ln of t minus t. Okay. So then u times v. Okay. Subtract this integral v du. Okay. V du here is t ln of t minus t times foot. Integral v du. Right? It is more complicated than the first one. But this is not good. Okay. But oh, sorry. This should be compute here. Okay. So this is not a good choice. So it turns out that this choice is does work for this problem. Okay. Right. So that's about the what's called the integration by parts. So just examples. You need to do this problem exercise. Okay. Any questions? If not, then let's continue with the next method is some trig integrals. All right, so a few things here. What we are doing is the some special form of integral. So in the form of a power of sine, power of cosine. So product of power, sine and cosine. Or this is multiple angles here. Sine mx, cosine mx. Or sine sine or cosine cosine. Tangent, cotangent, power, and its combinations. All right, so you see this combination, sine, cosine, tangent, secant, cotangent, cosecant. So the standard form is this one. Okay, so let's take some examples. Let's just go to the textbook. We just go over this quickly. And see, this is some useful identities here. What's wrong with this? So you identities. So Pythagorean identities. Pythagorean is just this one here. Sine square plus cosine square. Or this is also Pythagorean. So 1 plus tangent square is secant square. Or this one. 1 plus cotangent square is cosecant square. Okay. Actually, you just this one actually. You can derive the other from that one. Okay, so just let me remind you. So you have, this is the basic thing. Okay, if you divide by sine square x, then you get this is 1 plus cosine divided by sine. That's cotangent. 1 the sine is cosecant. Okay. Divide by let's see, by cosine square. Then you get sine over cosine, so tangent square. Cosine, cosine, that's 1. 1 over cosine is secant. Okay, so you don't need, you don't need to memorize this formula here, but you can derive that easily from 1. Okay. Other formula is half angles identities. Okay. So if you have a square, then you can get rid of this square, right, by doubling the angle. See, cosine 2x, it is negative. And then cosine square, you get rid of the square by double the angle of the cosine. Just difference, just this plus minus. Okay. All right, let's go over this one. Let's go quickly. Okay, so we define this two cases, n odd and n even. Okay, what happened with n odd? Okay, so for example, here sine to the 5th. Okay, so power 5, we split this 5 becomes 4 and 1. So just sine to the 4th, sine x. Okay, and we somehow replace this sine to the 4th by, okay, so this sine to the 4th is, well, doesn't matter why it becomes, maybe this. So sine square is 1 minus cosine square, and then you square. Multiply this out. First, you just compute the square. Okay, so 1 minus 2 cosine square plus cosine to the fourth. Okay. Okay, but this sign here makes that easy because it is now let's see. Okay, so this just multiplying this out, take the make this sign becomes negative sign by putting another negative here. Okay, so this step is okay. All right, so just multiply this out, integrate one by one. So this is integral negative sign. Integral of negative sign, just negative cosine. Okay, so this one is okay. Now this is 2 cosine square, but then you have this one here. Okay, so this is 8 times -8. Okay, so you see this is the form of, this is u square, this is du, by letting u equals cosine x. Right, so the du is just negative sine x dx. Substitutions. Substitutions. Give you this one here. Okay, so it just integral 2 u squared. The u squared is 1/3 cosine power 3. Okay, so this is power 4. Same similar substitution. So this u to the 4 sine x. We get this one. Questions? So that's the reason why we leave this one out here, the sine x, because this is going to be du. Okay. So this is with u equals cosine, sorry. U equals cosine x, right? So this is du, and this is 1 minus 2u plus u to the 4th. Okay. So just polynomial and replace the cosine back in the first step. Questions? All right, so let's do when is power even power. So sine x squared, cosine to the 4th. With sine x squared, you want to get rid of the square right here. Use the half angle and make the angle double. Okay. So just a substitution with the sine square with this one. It's double angle. I would say half angle identities or double angle identities, doesn't matter. You see, you can get rid of the square by doubling the angle, or you can make this into a square by halving the angle. Doesn't matter how you see this one. Okay, so you see this one, you get rid of the square, you get this one, and here you can get, you can directly integrate. Okay. So with power 4, what about power 4? This power 4 is let's see. Power 2 and another power 2. Okay. The power 2. So you have double the angle to x. You have this one. All right. And you still have this square. And replace this again by doubling the angle. But now the angle is now 4x. There. Okay. So with odd and you split the power into even and just remain 1. With the even and, somehow you use this half angle or double angle identities. Okay, so the type 2. Well, so this is a product of sine power m cosine m. One of these is an odd. This. Okay, you split this 3. 2 plus 1. So put 1 here. Okay. We have sine power 2. Sine replaced to become cosine. So cosine. Okay, so you have power of cosine. Here you have negative sine. Okay. So this becomes du. This becomes u to the negative 4. This is u to the negative 2. It's a polynomial. But if both are even, okay, so you double the angle. Sine becomes cosine 2x, double angle. And this becomes square again. Okay, you have this. Eventually you get this one. Okay. All right, so this cosine square, make it into double angle again, cosine 4x. There. Cosine power 3. Okay. Cosine power 3, you split this cosine. Take cosine out, and then power 2 replaced by sine. And then, let's see. You can replace this square by doubling the power, so become cosine 4x. Okay, so that's the trick of this. All right, so I will let you explore this type of integral. We just point out several things here, like this one. This is usually something that's a formula that's given, and you use this. Okay, so let's continue next time. Let's finish this this chapter. All right, any questions? All right, if not, then let's stop the record and then